Welcome back, everyone. We're looking at chapter 14b today, which is on angle sum and difference identities. This is really where we're looking at these formulas that we see on our formula sheet here. Now, because these are on a formula sheet, we don't really need to worry about the proofs or even really memorizing them. One thing I will point out is that our angle sums here, and our angle differences are here. I kind of like to think of it as linked. So I have my angle sum for sine and cos, my angle difference for sine and cos. The formula sheet does just put the sines and the cosines together. But there's sort of, if you do some different colors, you can kind of see I have my pairs. So the first pair we're going to look at is our angle sum identities. That is sine A plus B equals sine A cos B plus cos A sine B. Now just note it is addition, so my order doesn't really matter for the way I do this. For my my cosine angle sum identity, it is cos A plus B equals cos A cos B minus sine A sine B. I do have subtractions. My order is important. It's a cosine identity, so I put my cosines first. You shouldn't really have any difficulty with these though, because like I said, they are on the formula sheet anyway. So you're welcome to just turn to the formula sheet and read straight from there. So let's look at how these two identities, let's start with these two first. Let's look at how we can use these to solve for questions. Now, what our angle sum and our angle difference identities allow us to do is they allow us to find exact values. So we can use these to find exact values of our trig functions for angles other than 45, 30, 60, and let's put 0 and 90 because we also have exact values for those as well. For this first one, and we'll just do one of these because I think you guys will get the idea relatively quickly, is if I have cos 75, now that is not one of my exact values I have over here. However, 75 is in fact 30 plus 45 is equal to 75. So what our angle sum and difference identities allow us to do is to split my angle into two exact values. As long as I add or subtract to give me my angle, then I can use the rest of my identity with those exact values to get an exact solution or an exact answer. So if I do that for cos, I wind up with cos of 30 plus 45. It's addition. My order isn't super important. I'm going to kind of look at both anyway. So if this is true, this is kind of the same thing as being cos A plus cos B. So I know that cos A plus cos B, if I look at my value over here, is going to be equal to cos A cos B, which is going to be cos 30, cos 45, minus sine A sine B, which is going to be sine 30, sine 45. So because you can see we're multiplying, if I wrote that as 45 plus 30 and I did cos 45 times cos 30, my result is going to be the same. So if I get out my special triangles, if I draw those in, I can now get my exact values. Cos 30 is going to be adjacent over hypotenuse, which is going to become root 3 over 2. Multiplied by cos 45. There's two ways I could write this. I could write this as 1 over root 2, or I could rationalize my denominator and write that as being root 2 over 2. In general, it's normally easier to work with these if they have rationalized denominators. Also, you can see I've got my surds on the top line, which is going to make it easier when I'm multiplying across like so. So I would always try to simplify your values as much as you can. And that's going to be minus sine 30 is going to be 1/2 multiplied by root 2 over 2. So if I go ahead and do that, I have root 3 times root 2, which part of my properties with square roots is I can actually multiply those two numbers, which is going to give 3 times 2 is 6 over 4 minus root 2 over 4. So my final solution is going to be root 6 minus root 2 all over 4. Now, if I can simplify these, I would, but root 6 is not simplifiable. Root 2 is not simplifiable either. If we now have a look at our angle difference identities, and I've kind of have separated those out, but again, they're all in that one bubble as part of the formula sheet, angle sum and difference. If I look at my angle difference identities, it's the exact same idea before where I had sine A cos B plus cos A sine B. It's now just going to be sine A cos B minus cos A sine B. So that's going to be sine A cos B minus cos A sine B. So now my order will actually make a difference, but it also will make a difference with the type of questions I'm doing. So my order will make a difference. Again, just go up here, read from the formula sheet. You can't go wrong. Similarly, if I have cos A minus B, again, my sign in the middle essentially is just swapping. It was subtraction for A plus B. So it's going to be addition for A minus B. So there's my two difference identities. I did cos the first time. So let's choose sine for this one. And we'll do it on part B. Just note here for part A, I would need to use my angle sum identities again and do 30 plus 45. For this one, though, I have 15. So I'm going to write sine 15, sine 15. And again, I'm thinking of what two of my values can I subtract to get to 15? And some of you might think that's going to be 45 minus 30, which would be the correct answer. So this is going to become sine 45 minus 30 is going to be equal to, that's going to equal sine 45 times cos 30 minus cos 45 times sine 30. And again, if I use my exact values, I get root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1 over 2. Again, if I simplify that, I'm going to get root 6 over 4 minus root 2 over 4, which just so happens to give me root 6 minus root 2 over 4. And some of you, hopefully a little light bulb went off when we think of complementary angles. If I have 90 minus 15, that equals 75. So sine 15 should be equivalent to cos 75 because they're complementary angles. If we just kind of remind ourselves back to chapter 13b. Hopefully this all makes a little bit of sense. You guys have kind of seen the process now. All it is I'm just kind of thinking of out of my pairs I have over here. Out of these pairs, how could I add or subtract those to get my new angle? We are still a little bit limited to whole number angles, for example, and there's only so much we can do with these, but it does allow us to answer a much wider range of questions and find exact values for those solutions.